Alright, hello everyone. Welcome to our tutorial. Today it's going to be a little bit shorter so I can help with the projects and stuff. But we're going to go over association rule mining, which we went over in class. And then next week we'll go into distance metrics and then clustering and k-nearest neighbors. But for today we're gonna learn how to implement association rule mining. So as you learned in class, association rule mining is very useful when you're dealing with item sets, and you can determine rules based off of item sets and associate something like purchases for example, and it's very useful on that aspect. And the other thing which I'm going to quickly show you is you can also use the next two techniques we're going to use for exploratory data analysis as well. So association rule mining and clustering can also be useful to better understand your data set. And when you're dealing with a new data set that is very large, where it would be very difficult to make some visualizations to understand what's going on, using these two techniques can also be useful in getting you some insights on what the data looks like, as well as helping you find outliers, which I'll show very quickly. So with association rule mining, in Python there isn't one implementation of the Apriori algorithm, unfortunately. So there are a couple of implementations and a couple of different ways you can do it. I'm going to show you two ways. One is a custom implemented one that I found, which works really well with your own data set, which you can just use the code and it will give you rules, and you can set the confidence and the lift, and it will give you the rules. And you don't need to worry too much about the implementation. You can just use it. But the issue with that one is that it's not very streamlined and it can be a little bit slow. So with association rule mining, depending on how large your data set is and what you set your confidence and lift to, the algorithm can actually take quite a lot of memory and can run pretty slowly. So this implementation works pretty well with the stock code, but I'll also show you another way using a tool that I found called Orange. And then later in this tutorial, I'll actually show you that Orange also creates a graphical user interface where you can actually do data mining live. So I just found out about this just recently. So I'll present it here, and you can also use Orange for your projects as well. It's very similar to Weka. So let's first look at the data set that we're going to be dealing with. So I found this implementation on GitHub over here. So I'll post a link to it, but someone implemented the Apriori algorithm on this integrated data set. And this data set comes from the New York City open data, and it's basically about small businesses essentially, and ones that are run by different groups of people based off ethnicity and other kinds of information. So we're just going to, just for example purposes, show how you can run the Apriori algorithm. So if we take a look at the data, you can see here, it's basically an item set. In this sense, it's not really purchases or anything. Each row is a different business, and it has different information about each business. And you can just straight off the bat use association rule mining to see associations between the different points. So with this code, you can actually just run it directly in Python. So what you can do is similar to how you run other Python programs, you just do Python and then the file, and then you can just set the data set. So if you just do it by default, it will use a default lift and confidence. So if you just run this, it will create the item sets, and then it will also set the top 5 rules. So in this case, for WBE, it's a non-minority, and this is, I believe, women-run businesses. And then you can see here with the other rule sets, you can see where other businesses are based off of the lift and the confidence. You can also set your own lift and confidence. So in this case, you just run the same code, except for you can put your support, and you can put your confidence as well. So if we run this code, it will basically just only include the the rules that fit within this confidence and lift. And that's how you just run it very quickly. So I'm also going to show you another tool which I found called Orange. So I'll upload this code and you can use it directly. And the main advantage to it is, as I said, you could just give it a CSV and it will already give you the rules based off that CSV, which will be very helpful for you just to get the rules very quickly. Another tool that I actually found is something called Orange. And Orange is really interesting. I wish I knew about it earlier, but it's data mining implemented in Python. But in addition to just being code, it actually creates a graphical user interface, which I'll show you very quickly. And you can automatically make the graphs and charts and stuff without having to write code, which is pretty interesting. And it also has a kind of flowchart way that you can actually do analysis. So it also comes with, you can also use the Orange library, and you can run association as well using code. So I'll show you that very quickly, and then I'll be able to show you the actual graphical user interface, which ties in the stuff that we previously talked about. So again, there are two documentation here that you can read. The first one that I'm just going to demonstrate here today is just going to be with data that's already within Orange, and applying a priori and association rule mining on a transactional database, and then some other examples. And then this documentation I'll leave for you to read, but it explains how to do it with your own data set. It can be a little bit complicated because it deals with cleaning the data and parsing it, but you can go through that as well and be able to apply it. The main part with each implementation of a priori is you have to understand what form the data takes in, such that you can manipulate your own data to fit within that form. So to make it easy for you, I provided that code which just does it in a CSV, which makes it a lot easier. But in this case, you can learn how to manipulate the data, and you can learn a thing called one-hot encoding, which is useful for turning categorical variables into binary. So you can turn a set, so let's say you have 3 or 4 categories. Instead of having one feature with 4 categories, what you can do is you can have 4 features that are binary. So it's a 1 or a 0, which is useful for certain types of algorithms. So this tutorial goes over it. I'm not going to go over it today for the sake of time. And we can go ahead and look at the results from it. So in this case, you just import the library. So you would install it like you normally do, pip install orange. And then here it opens up a market basket set of data. And then it basically, you just set orange association rules, sparse inducer. So this is just because this data is a sparse matrix, meaning that it has lots of zeros and very few ones. There's optimized Python code that works well for sparse matrices. And then here you can set the support, and then you can just print out the rules. So here you can see with this support and with this confidence, people who buy diapers also buy cola. And then you can, so in this way you don't really set a right-hand side or a left-hand side. It just sets, it just determines rules based off of the purchases. So this is a similar example with storing the results. So you can just look at the confidence on each, and then in this example, it uses a different set of data. This is more on text data. So it actually so it actually parses out the text data and does it that way. So you can read through the documentation. It kind of explains good ways to manipulate your data such that you can use Orange to be able to do it. I would really only use this method if the one that I gave you doesn't really work well, or if it's running very slowly. Just simply running the Python code that I showed you can actually get you the rules pretty quickly. The next thing I wanted to show you, this is an implementation in R. So I know that using R, I briefly talked about in the beginning, and some of you might know how to use R, and for those who don't, it's okay. My favorite a priori implementation is actually in R, because it works a lot faster than the ones that I've previously used. So I just wanted to show it to you very quickly. So this is just using the A rules library, and in the same way, you just you can set your support and your confidence. And in this case, you can actually set a right-hand side and a left-hand side. So in this case, on my left-hand side, I'm just going to put default, meaning that it's going to take all of the transactions. And on the right-hand side, you can actually specify what you want on each side. So if I run this code very quickly, so in this set of data, it's just it's a data set with information about adults. And let's say, for example, we don't know anything about this data set. The reason that I really like Apriori is you can actually get information about the data set by the rules that it builds, and you can find outliers. And you can get outliers just based off the rules. So if we run this code here, we set the rules, we can sort the rules, and then it'll just list the top 5 rules. So in this case, the results sometimes with Apriori can be pretty obvious. So in this case, hopefully you can see this down here. Relationship equals husband, and then sex equals male, which is like pretty obvious. But the thing that might not be pretty obvious is, so why is the confidence in this case less than 1? Because theoretically, anytime someone's a husband, the gender should be male. So what this can show you is maybe you have an outlier, and you can actually use association rule mining to find outliers or learn things about the data set that you don't know. The next one, if you read it, here it's saying that it's married, it's civilian. So civilian, relationship, husband, sex equals male. And then you can see as well working class. I guess they have some military data, but in this case it's private, and then United States equals male. So this is a quick way you can get these association rule mining. You can also change what's on the right hand and left hand side. So you can remove sex equals male, for example, and then you can just see information where race equals white, and you can run the rules as well, and then get a new set of rules. So in this case, you can see what's common. So it's common for married civilians, for white, and a couple of other rules which are also pretty useful. So this is an implementation you can use in R, and you can use this. You would use this only if the other previous ones don't work very well. When I was actually doing a project on my own, the Python implementation was taking too long. It was using a lot of memory, so I actually used R on a server, and it actually worked a lot better. So that's why I wanted to present it here. The last thing I wanted to present to you today, before I help with the projects, is Orange. So Orange is a really interesting tool. So for Windows, you can just go down here and download it, depending on or whatever operating system you're using. And in Linux, just to run it is you just run Python Orange. So I'm just going to open up. Open it up here. So it's actually a very awesome interface you can actually use for your projects. So I didn't have I actually just learned about this, so I didn't really have that much time to play with it on my own. But the tutorials are pretty useful. So in this case, we learned a couple of things in this class. One is classification. So this is I'm going to show you a tree implementation. This is clustering, which we can probably go over next week, and then cross-validation, which we talked about last week. And I can actually show you an implementation here where you can quickly try different types of classifiers and be able to read the confusion matrices. So if we just open up this example, here what you can see is you can have a file. So in this case, it opens up the iris data set, which is already saved here, but you can actually go and open up CSVs and all these different types of, so it comes with a lot of data sets, but you can also open up your own data set. And then here you can pick the algorithm you want to use. So in this case, we're going to use a classification tree. We're going to use entropy, as we learned in class. And then here you can do a thing called pruning. It's something that we briefly spoke about, but to prevent overfitting, what you can do is you can prune your tree. So instead of building the whole tree out, in this case you can set parameters such as the minimum instances in the leaves. So you don't want the leaves to have just one instance, because then it might be overfitting, tuning it based off of the noise in the data set. And here the depth of the tree is 100. So these are just some sample parameters you can use. You can change these parameters, use cross-validation, and determine what's the best, as I showed you with pipelines. So what I would recommend is if you wanted to quickly get rules and work on your projects, maybe use this tool just to prototype very quickly. And then if you really want to fine tune it, let's say if you're working on a project for your job or whatever, then maybe you'd want to use the grid search and stuff like that, as I showed. But this could be a quick way that you can quickly prototype. So again, so it runs the classification algorithm, and this is really cool. This is the classification tree viewer. So similar to I showed you how to implement it in code, it actually builds the tree, which it's hard to zoom out. On a full monitor, it actually looks a lot better than on the projector. But here again, you can see that it's going to separate it here based off petal length. If less than 2.45, then it knows that it's Iris centosa. Otherwise, it goes through. And then the other really cool part about this is you can actually see this little pie chart, and it can show you where the false positives are, which are kind of cool. It could be a great way to quickly verify your data and take a look at it. So this is another way you can again use the look at the trees, and then you can also get a scatter plot, which looks at the data. We already kind of looked at this before in our previous tutorials, but the really cool part about it is you can do show class density, and it will actually show you the way that the tree is classifying, so you can see which false positives are where, which is kind of cool. So you can actually see how well your classification algorithm is performing, which is very useful. And you can also change the different axes on the different the different sets of data. So you can actually see which data sets are separable in which way. So it can also help remove features or ones that are very correlated or ones that are not separated very well. So that's also very useful. And then the last thing in this example you can do is a box plot, which doesn't show up for me, which I don't know why. The other thing we can do is you can also look at the other tutorial. And this one I think is very, very helpful. So this is very similar to what we did last class, except for in this case, what it's going to do is you're going to open up a file. It shows you how you can look at the data table. So here you can actually look at the raw data, kind of like how you would look at in Excel. And then what you can do is you can now do a test and score. So you can do cross-validation, and then we're going to use 3 different types of classification algorithms. So you'll learn about logistic regression and support vector machines very shortly. And again, random forest is very similar to decision trees, except for it makes multiple weak learners and then ensembles them together. And it also uses boosting. So you can set the parameters for each one, and just very quickly, logistic regression fits a sigmoid function, so it's like an S shape, and then it fits that and classifies it that way. And then a support vector machine is a linear classifier, so it puts a line in between your data set, or you can use a non-linear kernel where it could put like an arc around your data set, which you'll learn very quickly. Here you can do test and score, so it will, for example, here use tenfold cross-validation. You can also use the other types of cross-validation we talked about. So you can do training and testing, you can do holdout, and it also shows you the results. So it gives you the area under the curve, what I talked about last week with the ROC curve, and it also gives you other, like your F1 statistic, your precision, your recall. But actually very useful is it shows you your confusion matrix. And this is pretty cool. So by looking at the confusion matrix, you can see how each algorithm performs, and you can evaluate your classifier based off the confusion matrix. So you can look at, and they're very similar in this case because the data set is pretty small, but you can see where the false positives and the ones that are incorrect versus the ones that are correct, and you can make decisions based off your classifier using this tool. So again, I haven't really used it that much, but there are tutorials on their website as well, and I think this could be a useful tool as well for you to quickly prototype your results. And you can probably even just play with these 3 algorithms if you're doing classification, and you should be able to get pretty good results for your project. So hopefully that was useful. I can now help you guys out with your projects.